Good morning, students. Today's topic is shift microoperations. We learned that a microoperation is an elementary operation that is performed on the data stored in the register. What are the microoperations? Arithmetic, logical, and shift. What are arithmetic microoperations? Can anyone tell me?
Ma'am, addition, subtraction,
Yes, very good. Decrement.
and all that, increment, decrement,
And what about logical microoperations? What are they?
and or
and or, XOR,
not.
Now we have done with arithmetic and logical. We have to do shift micro operation. The last one which is left to be discussed is shift micro operation. What is the meaning of shift micro operation? This means you are shifting the bits. Suppose in a on a bench, if there are two students sitting and there is a place here, and another student arrives from this way, what does he do? He tell his friends to move. That is nothing but shifting. He will shift here, he will shift at this place, and then this place will be vacant and you occupy that place. Like that, if there are these bits, you can shift these bits to this one is shifted out, then this one would come here, this zero would come here, and this one would come here. This is like, look at here, this is shifting. How you are shifting your friend? Like that, you are shifting the bits. And what is the use of shift micro operations? It is used for serial transfer of data. Serial transfer of data means what? One by one. If there is a way here, if there is a way here, and there is a wall here. So one by one, students would come out. First, this student will come out. This is known as serial transfer, one by one. Then next, this student will come out because there is only one way, and this way is blocked, and through this one by one transfer of students happen. Likewise, transfer of bits happen, and they are also used in conjunction with arithmetic, logic, and other data processing operations. And the important thing here is that the contents can be shifted to the left or to the right. If suppose the wall is here and you come from this side, you tell your friends to shift. This is left shift. If your friend is moving this side, it is left shift. If your friend is moving another side, that is right shift. You can perform left shift or right shift. And here there are three types of shifts: logical shift, circular shift, arithmetic shift. How do you denote them? You denote them with SHL for shift left on the contents of register R. SHL is shift left, SHR is shift right. And what are these two? These two belongs to logical shift. Then the second type is circular shift. How do you designate circular shift? CIL in circular shift left, L left. CIR circular shift right, because this R is there, no? R right. These two belongs to circular shift. The third category is arithmetic shift. And how do you denote it? A arithmetic SHL. Arithmetic shift left. L denotes left. SH denotes shift. And if there is no A, it is logical. If there is an A, it is arithmetic. A, S, H, R, arithmetic shift right. So these three types of shift operations can be done in a computer system, and let us look at each one of them. How, what is the um, operation? So a logical shift is one that transfers zero through serial input, and symbol SHL and SHR denote logical shift left and logical shift right. And what do you mean by this? This is logical shift left the contents of R1 and transfer that shifted contents back to R1. This means that, do you remember this? This is a replacement operator. Let us look at an example. Um, 0, 1, 0, 1. This is our R1. Now we want to perform SHL. If I have to perform SHL, then what do you do here? This, you shift the contents to left. Left means, you see here, this one is shifted to left here, and this 0 would be shifted here to left, and 1 would be shifted here. Now what is left? This 0. 0 is said to be out of the register. This is shifted out, and then you have to transfer shift, you have to transfer. So what is happening here? This 0 is sent out, and you have to transfer 0. Here you have to transfer 0 because it is logical shift. In logical shift, you transfer 0 through serial input. When you shift the contents to right, to left, to at this is rightmost position should receive a value 0. All right, here this 0 is transferred in, and this one is transferred out. This is out. And when we say shift right, then what happens? Let us take again the same bits. This is shifted to right side. The 0 is shifted to right. 1, 0, and this one is out. Apparently, you have to transfer 0 at the leftmost position here. You transfer 0. Do you understand logical shift? What do you mean by logical shift?
Yes, ma'am. Understood.
Okay. Can you tell me? We'll take all of you. You have your pen and books with you. Take one number and tell me after performing shift operation what happens. Take 0011. What is the result of shift left and shift right? And tell me its decimal value equivalent, and after performing left and after performing right, what are the decimal equivalent? Yes, students, anyone has done it?
Ma'am,
Yes.
ma'am, shift to left is 0110.
0110.
Shift to right is 0011.
Shift right.
No, ma'am, it's 1001.
Zero double one zero, ma'am.
0110 is
Zero.
left or right?
Okay. Zero double zero one zero, madam. Shift
Zero
right.
zero 10, right?
How?
We are adding zero, ma'am.
We are shifting the zero to right, right? This is right. Right of the zero is this side. And,
Ma'am,
yes, tell me. Tell me, students. Shift left is right. Shift right, you tell me. Logical shift right.
0010, ma'am.
0010. Why you are getting 0010?
0001.
Right. 00011, ma'am.
Yes.
very
Who
good.
said yes? Yes, who said 0001?
Ma'am, me,
Okay,
ma'am.
Mahesh, tell me the reason.
Ma'am, the bits are shifted to right now, ma'am. So we have to add zero to the left side, ma'am.
Yes, very good.
So at the end the one is removed and zero is added to the
One
left.
is removed. That is known as serial out. That is,
Yes, ma'am.
you are transferring it out and you are transferring zero in. So this zero is transferred in. This zero is transferred in. And then this zero is shifted right. This zero is shifted right. And this one is shifted right. And the last one, the rightmost one, is serial out. It is sent out. This is shift right.
Right.
Shift left means this one is shifted to left and this one shifted to left, this one shifted to right. What is sent out? Zero is sent
Zero.
out. This zero is sent out. All the students are clear with this now? Are all students clear with logical shift left and logical shift right? If no, we'll take another example and discuss.
Yes, ma'am. Clear, ma'am.
Ma'am, explain
Okay.
example, ma'am. 0011.
Yes.
Once again.
Once again. Okay. Here. 0011. Okay. We will perform now shift left. Okay, shift left when we are performing. This bit is there. This is the leftmost bit. This is the rightmost bit. This is rightmost. This is leftmost. In shift left, what happens? You transfer this rightmost bit to its left position, left direction. So this goes here, and this goes to its left. This goes to its left. What now? What is left? This leftmost bit
0.
is, yeah, leftmost bit is left. Okay. So what you have to do? You send it out. This is transfer
Serial out.
out, serial out, and now this position is empty. What you have to do? You have to serial in. You have to transfer
0.
in. What you have to transfer in? 0. So
0.
this is logical shift left. Now logical shift right. Let us take the same number, binary number. This is logical shift right. This is what? Leftmost. This is rightmost. Now you have to transfer the bits to rightmost position, to right position. So this bit will be moved to its right. This will be moved to its right, and this will be moved to its right. Now what is left? This one is left. This is serial out. One you send out. And what you have to transfer in? Here there is a vacant, right? There is a vacant spot here. So to that spot you have to push in 0 because it is logical shift. Whenever you are performing logical shift, you transfer 0. You transfer 0 in the leftmost position when you are doing right shift, and rightmost position when you are doing left shift. And when you are performing left shift, what happens is this leftmost position is sent out. When you are performing right shift, this rightmost bit is sent out, or see, it is also known as transfer out or serial out. Is it clear now to all of you? Let us
Yes,
move
ma'am.
ahead.
Clear.
Okay, let us move ahead now. Next type of shift is circular shift. Circular shift is also known as rotate operation. Why it is known as rotate operation? Because the bits are circulated around the two ends without loss of information. You see in uh, logical shift left and logical shift right, there is a loss of information. How it is a loss of information? Here, this bit in uh, shift left, this leftmost bit is lost. Lost means it is sent out. Here, this rightmost bit is sent out, so it is lost. So there is kind of information loss. But then in circular shift, there is no loss of information. When if you take an example, this 0011, all the bits are preserved. However, there is a change in their position, but no bit is sent out. Only there is a change in the position. What happened here? If you consider this binary number, if you perform CIL operation, which is circular shift left operation, then what happens? This you perform in a similar manner. This one is shifted left, this one is shifted left, this 0 is shifted left. What is left? Uh,
0.
this 0. And what is the vacant position? This one. So what do? You bring this back like this. This is known as rotate or circular. Look at here, this is in circular fashion. You are shifting the bits. This 0 would be shifted here. And from where you are getting the 0? You are getting the 0 from the leftmost position of the binary number. So there is no loss. It is just circulated, rotated. When you consider this operation CIR, which is circular shift right, take the same number, which is 0011. So in circular shift right, what happens? This 0 is shifted to right, this 0 is shifted to right, and this one is shifted here. And what is left? What this one is
One.
left. What do you do now? You transfer this one in a circular fashion to the other end. Okay, to the other end means in CIR, which end? To left end here. In CIL, to the right end. Do you understand this, students?
Yes,
Yes,
ma'am.
ma'am.
Okay. Take one example and tell me. Let us take another example. Take this number 0101 and tell me. Take 0101 and tell me about CIL and CIR.
One zero one zero, ma'am. Circular left shift.
Circular left
Shift.
shift 1010.
And right also 1010.
Right also 1010. Right, yes. In left, what is happening? This 0 is moved to this position. And here, this one is shifted to this position. Yes. Did everyone get this answer?
Yes, ma'am.
Okay, students. Let us look at arithmetic shift. Arithmetic shift means uh, it is a micro operation that shifts signed binary number to the left or right. What do you mean by signed binary number? When you represent a positive and negative, both the numbers, then it is known as a signed number. An arithmetic shift left multiplies a signed binary number, and arithmetic shift right divide number by 0. And arithmetic shift must leave the sign bit unchanged. Okay, because of the sign of the number, it remains the same. Look at this register. The leftmost bit is a sign bit. When you are representing numbers in negative form, this number denotes the sign bit. And what is the sign bit for negative number? It is 1. For negative number, sign bit is 1, and for positive number, sign bit is 0. If there is a 1 at this position, it signifies that it is a negative number. If there is a 0 in this leftmost position, it denotes that the number is a positive number. All right. So then we have to preserve the sign bit whenever we are performing arithmetic shift left and arithmetic shift right of micro operations. So consider this number. Let us take an 8 bits number. Okay, 4. How do you represent 4? if you consider this 4 to be minus 4, then to represent 4 we require 4. Okay, 0 2 1 1 2 4. Okay, students, try to understand here. Negative number, this is minus 4. If you look at here, this this denotes 4, right? This is 4, and the last bit, this signifies that it is minus 4. Okay, this is minus 4, and this number denotes, this one denotes that it is a negative number. If it is a plus 4, it would be 0 1 0 0. These 3 bits for 4 and this bit for sign. This is plus. This is plus 4. If you have to perform arithmetic shift operation, then you have to preserve this sign bit. If it is a negative number, you have the result should also be negative. So how do you do that? If you have to perform a right shift, arithmetic shift right operation on this number, what is this number? This is minus 4. Then what you have to do? You transfer uh, this one here, and then transfer this one here, and this transfer 0 here, and bring 1 here. Okay, why are you bringing 1 at this position? Because it is a negative number. Okay, students, are you able to understand these things?
Ma'am, yes, ma'am. But when we include that one for a negative sign, then that will then there will be a change in the actual decimal value of
Yes,
4 now.
very good, very good. And then what will be the result? Actual decimal value will change. You are absolutely right. And how it changes? Whenever you are performing a shift left, it is like multiplying by 2. Whenever you are performing right, it is like dividing by 2. Okay. The problem in this is we are considering only 4 bits. That's why it would be a problem. Shift left, when you perform shift left, it is like multiply, and when you perform shift right, it is like divide. Okay, right. So when you divide the number, it should become 2. Okay, actually what happens is this bit, oh, 1 minute. Okay, students, here what happens is this is actually, if you consider 8 bits number, it would be easy, but then I'll try to explain you with this only somehow. This is our number and this is our sign. Okay. Now, whenever you are performing shifting operation, this bit you have to leave as it is. Then this one would be transferred here. This zero would be transferred here. Here you are transferring zero, and then this uh, sign will be preserved. Preserved means you just copy it from this position to this same position. You copy. So then what happens now? The number would become 2 and the sign would remain as minus. And then let us do for left also and see. To do it to left,
Ma'am,
yes.
ma'am, are we performing circular, ma'am, here?
No, no, we are not performing circular. We are. It is like it is logical. It is extension to logical.
Okay.
We are not performing circular. Okay. Now more two examples we'll see. I'll try to make you understand. Um, Here what happens? Uh, Let us do ASHR. Uh, SHR is over left. ASHL. So this zero is shifted here. This zero is shifted here. This one is shifted here. And then this sign is preserved and copied. And here you transfer zero. So then what happens to this number? This number would become, earlier it was 4, now it becomes 8 and sign will be preserved as minus. Okay,
Now
I'll
we
give
have to divide that with 2.
no, we don't have to divide by 2. Uh, the result will give you 2. That this shifting operation would give you 2. We don't have to do anything. The arithmetic shift left leaves the sign bit unchanged and shifts the number to the right. Thus, Rn minus 1 remains the same. Rn minus 2 receives the bit from Rn minus 1 and so on. And the bit in R naught is lost. R naught bit is lost. This is shift right. In right, this bit is lost. This is lost. This is same as students. Just see that this concept is same as shift, logical shift left and logical shift right, except that you are adding here a, which implies it is arithmetic and which implies that it is actually operating on signed numbers, and signed numbers means they can be positive or negative, and if a number is negative, the rightmost position will take a value 1, and whenever you are performing left shift operation, you have to perform the shift from the, this is R naught and this is Rn. From Rn minus 1 position, you have to perform shifting. Rn you should leave as it is. Why you should leave Rn as it is? Because that denotes the sign.
Sign.
That denotes the sign. Okay. So I'll give you some numbers. Let us see whether you are able to do or not, and then we will understand it in a more clear manner. I'll give you a larger number, perhaps 6-bit number. So this one, this is Rn, and then 0, 1, 1, 0, 1. Okay, so what can anyone tell me what is this number in decimal?
Ma'am, 45.
Is it 45?
Ma'am, sorry. Uh, the left one we have to ignore, na?
Yes, Lord.
Is it a sign?
Yeah, it is a sign.
Okay.
13. Minus 9.
13.
Is
Yes, ma'am. 13.
13. And what is the sign?
Sign is negative.
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 So this is which number? This is a negative number. This is a signed negative number. So it is minus 13. Now perform ASHR. Perform ASHR and tell me what is the value.
Zero zero 1101.
0, 0, 1, 1,
01.
0. This one is lost.
Okay.
This is like logical. In
Okay, ma'am.
logical,
One
what have
zero
you
Zero
done?
one
zero
one
one
zero
one.
one zero.
Uh, this is 1, 0, 0. Yes, again, can you tell me again?
1011 010.
1, 0. Sign. Are you including the sign bit or not?
Yes, ma'am. Sign bit also.
Okay, then tell me 1,
0
0,
11
1, 1.
010.
No, no, no.
Ma'am, 100110.
Yes. Why? Who is this? And first tell me who is this?
Mahesh, ma'am.
Mahesh, tell me the reason.
Ma'am, you told no, ma'am. It is like logical. So I eliminated the rightmost bit
Yes,
one,
very
ma'am,
good.
and I added zero to the left end,
Yes, very good.
and I added the sign at the left end again, ma'am.
Very good. So then now what is this number?
100110.
No, in decimal.
Ma'am.
5.
This is 5.
5.
Is this 5?
6.
6.
6.
It is 6. It is minus 6. And what we understood, when you perform arithmetic shift right, it is like division. Divide the number by 2. So it is 13. When you divide the number by 2, you get
6.
6.5, but then
5.
it is an integer division, so you get 6. Is this right? All of you are
Yes, ma'am.
okay with this?
Ma'am, can you explain again?
This one? Okay.
Yes, ma'am.
Yeah. Look, students, what happens here is this sign bit, you just keep it as it is. Okay, don't touch it. You don't touch the sign bit. Keep it as it is. Take this number. What is this number? This number is 01101. As Mahesh said, he eliminated this rightmost bit. This he eliminated. After eliminating, what happens? You are shifting to right. This is 1, 1, and then this is 0. And then you have to transfer. Students, am I audible?
Yes, ma'am.
Okay. So here what is happening? Consider only this number. In this number, you just transfer out the right and then you shift other bits to the right and you transfer 0 here and 1 minute, students. Okay, student, sorry about that. So then now you have done this right transfer, except this sign bit, and then you just put the sign bit as it is. Then now what you obtain here? This was 13, and after arithmetic shift right, this would become 6. Actually, it was minus 13 and it would become minus 6. Is it clear now?
Yes, ma'am.
Okay, can
Yes,
you
ma'am.
tell me now? Yeah, you tell me now about this one. Um, ASHL.
111010, ma'am.
Triple one.
010.
Okay, 1 minute.
Ma'am.
Hmm.
One one
Tell me.
one 1010.
111010. So what is this decimal?
26.
26.
Okay. So 13 into 26 is 13 into 2 is 26. So arithmetic shift right is into 2, means multiply by 2. Arithmetic shift left is divide by 2. Arithmetic shift right is shift left is multiply by 2. Right is divide by 2. Okay. Then let us look at the circuit. How you can implement whatever we have learned in the form of a circuit. This circuit has got 4 multiplexers, and 4 multiplexers are having 2 inputs. Each one is 2 by 1. 2 inputs, 1 output. 2 inputs, 1 output. And then for 2 inputs, how many selection lines you require? Only one. So this is select line. Select line S is common to all the multiplexers. Here you are connecting, tapping and connecting, tapping and connecting. So you are connecting this selection input line to all multiplexers, followed by you have, this is 4 multiplexers, so you have 4 bits, A0, A1, A2, A3, and you get out 4 outputs, H0, H1, H2, H3, 4 bits in the output. When you perform, now can anyone tell me SHL means which bit you are uh, transferring out and which bit you are transferring in, from which side you are transferring in and from which side you are transferring out?
Ma'am, transferring from A3.
Transferring from A3.
Yeah.
A3. This is A0, A1, A2, A3.
And then A
So
naught will be replaced by 0. If what is sign
yeah,
is
in logical shift,
ignored.
in logical shift you replace 0. You bring
Yeah.
in 0. So here you are, what are you doing here? You are getting, here you are getting a new value, means which is 0, and then you are shifting. So if you look at here, this is serial input. Serial input, this is for right shift. For right shift, you have to do serial input at the A3 position, right? At the A3 position, you have to serial input. So serial input is here, and then this one is A0, this is A0, this is serial input. The zero, you check 0, and then A1, this is with shift, right shift, and then A2. Okay, this is right shift. And then left shift means what? This multiplexer, when the select line is 0, when you transfer 0 for the select input, it behaves like a right shift circuit, and when S is 1, it behaves like a left shift circuit. And here it is a logical right shift and logical left shift. When it is left shift, what happens is here you are transferring at the rightmost position, right? For left shift. Here you get the new value which is 0, and for right shift here you get. So leftmost position. Same thing is depicted here in this circuit. Here this is rightmost. This one which is inserting at the leftmost position for the shift right, and inserting at the here. Okay, this is shift left. 1 means shift left. 0 means shift right. Okay, do you understand, student, this circuit?
Yes, ma'am.
Okay, this logic shift unit. This is ALU, arithmetic logic shift unit. Okay, so it is in short known as ALU. It is abbreviated as arithmetic and logical unit, which has arithmetic logic and shift operations supported. Now your task is, today's task is to understand this, analyze this. Okay, analyze. Okay, is Vamshi there in the class? Analyze and understand ALU, because we studied arithmetic, and we studied logical, and also we studied shift. So all that you are combining into one unit, which is known as ALU. So today's task is you have to analyze and learn ALU circuit. If Vamshi is there, he can discuss arithmetic circuit. Okay, I think he's not there. Students, did you all go through multiplexer? Did you understand multiplexer? Please respond in chat window. Did you understand multiplexer or not? Okay. Others? Only Pawan? Other students? Yes, very good, Kavita. Other students? Yes, very good. If you have understood multiplexer, Then let me quickly walk you through this arithmetic circuit. Okay, look at this arithmetic circuit. It has got four 4 by 1 multiplexers. There are four multiplexers. Each one is having 4 by 1, capacity. Means four inputs and one output. What happens here in this circuit, we'll see. These two S0 and S1 are the selection input lines for all the four multiplexers, S0 and S1. And this S0 and S1 would control which input is sent out. If both are 0, 0, then which input will be sent out? 0 will be sent out. If both are, if it is 0 and 1, one first input will be sent out. If it is 1, 0, then second output will be sent. If it is 1, 1, then third will be sent out. Okay, in this manner, input which input is to be sent out is chosen by the multiplexer through selection input. All four would get same selection input lines. Okay, this point is clear. And then this C in. C in is what? Carry. We have learned C in when we studied about binary adder and binary adder subtractor. What does C in do? This C in would give either 1 or 0. If it gives 1, then it is like an extra carry which is coming in. Depending on the operation, if it is addition, then extra carry would just add 1 plus 1 0, carry 1 0, carry 1. If it is addition, this is an extra carry, C naught. This is C naught. If it is subtraction, it is uh, used for obtaining the two's complement. Depending on the type of operation which is uh, you know um, decided, based on that, by this selection input lines, based on that, this C in, that extra carry which is coming in, will function. So here A naught is directly given as input to this full adder. There are four full adders. Full adder is a combinational circuit that performs 3 bits, addition of 3 bits. So A naught is directly given to X naught everywhere. A1 is X1 and A2 is X2 and A3 is X3. Directly first, if you recall, when we learnt about adder subtractor also, in this circuit, A was directly given to the full adder, whereas the B was, given first to the XOR gate, and based on the mode, the output of the XOR, it is determined whether to perform addition or subtraction by this full adder. Likewise, A is given Okay, students, are you able to understand here what I am doing? Not what this circuit is doing is taking A as it is, and this B is directly given to the zeroth input of multiplexer and complemented and given to the first input of the multiplexer, and second and third input would receive 1 and 0. This third input would receive 1. This 0, actually the direct input is 0. 0 is complemented here. So this is 1. There are two lines going out from this zeroth line and this one line. This one is given as the third input to the multiplexer, and 0 is given as the second input to the multiplexer. And B value directly given as to the zeroth input and complemented and given to the first input. So now can you tell me, if it is S0 and S1 are 0, 0, then what happens? If S0 and S1 are 0, 0 and Cin is 0, then it is just normal addition. A is anyone directly given, and B is also directly given. Because both are 0, 0, this zeroth input of multiplexer will be chosen and sent out, and it is sending out to the second input of the full adder. First input anyway it is receiving from A, second input it is directly receiving from B, because S0 and S1 are 0, 0. So it is just addition. If both S0 and S1 are 0, 0 and there is an extra carry, then it is A plus B plus 1. Why plus 1? You are getting extra carry from here. So you will have A 1, 0, 1, 1 suppose, and 0, 0, 0, 1, and there is an extra carry. So this is A plus B plus this extra carry. And when this S0 is 1 and S1 is 0 and Cin is 0, it is A plus B complement. Why B complement? When it is 0, 1, this first input is selected, and what is first input? Complement of B. Here B is complemented. For all the multiplexers, the first input is complement of B. But when Cin is also 1, it is subtraction with subtraction using 2's complement. Our students, is this clear?
Yes, ma'am.
Okay, very good. Then you just go through it, and today we have completed that chapter. In next class we will start next chapter, and then you all have to do assignment. The 18, 19, 20 questions are completed.
Yes, ma'am.
Yes, ma'am.
Completed.
Completed.
Yes, ma'am.
Okay. Then remaining questions you have to do. What are the remaining questions? Okay, list out arithmetic micro operations you have to do: 21, 22, 23, 24, 25, 26. This week you have to complete all of these questions. In your assignment notebook, just write down from 21 to okay, all the questions. It's not moving. I don't know. So there might be some problem. So all the questions of this unit 2, register, transfer, and this chapter we have completed. Register, transfer, and micro operations. So all the questions, whatever are there in this section, you all have to start writing and complete in this week. Next week, whenever I take class, I'll ask you about this. Okay, students?
Okay, ma'am.
Okay, then.
Ma'am,
Yes, Pawan,
ma'am,
tell me.
ma'am, if there are mistakes in our assignments, then would you give us a proper notes?
Uh, Notes are already there in the classroom for that register, transfer, and micro operations chapter. You go through
Yeah.
that. Okay?
Okay, ma'am. Okay.
Okay, students, bye.